All right, welcome back, folks. Hopefully your backs aren't hurting too much from shoveling all that snow and ice. We are continuing on in our journey through the structure of naturalism. So we are heading next. You can see we were just on genetics and DNA. And you can see natural selection is going to be our next thing. But before we quick jump into that, let's just take a look at where we've been. We started out with cosmology. We looked at the universe and we saw that everything does not look billions of years old. And because things don't look billions of years old, this whole naturalistic version of history has no legs to stand on. Because without those billions of years, life isn't going to come from non-life, the genetic code isn't going to code for itself, and everything else just tumbles to the ground. Even so, we said, okay, let's pretend that you've got billions of years to work with. Even with that, life does not come from non-life. That's what we found in the Origin of Life chapter. And then in genetics and DNA, we found that when we actually look at the genetic code, things are going down, not up. So far from humanity evolving and getting better and better and better and better over time, we're actually getting worse and worse and worse and worse with every single generation. It's the exact opposite of what we'd expect to see if the story of naturalism and the grand theory of evolution were true. But of course, it's exactly what we'd expect to see if the biblical version of history were real. You know, where you have everything created perfect, but it's all been in a constant state of decay ever since the fall. That's exactly what we're seeing in the real world. And next up is, of course, natural selection. So we'll get our background changed. Anybody know the significance of the tree in the background? Tree of Life. Very good. Nice job. Darwin's Tree of Life. So if you haven't written down the title already, there it is in much bigger letters for you. The expert that will be supplying us with some quotes in this section, along with others, Dr. Don Batten, PhD plant physiology. He's over in Australia. And if we have some time near the end of the semester, we'll talk with him a little bit more than this section. Really smart individual. He's been doing this for a really, really long time. And he does an excellent job explaining why natural selection can't get you the amazing variety of things we see in our world today. And that's ultimately what we're going to be taking a look at as we begin this section. So this is Darwin. And this was not the original cover of his book, but The Origin of Species by Means of Natural Selection. So this was his seminal book, and it's probably the most referenced book in the scientific community today. It's probably the most famous, too. It upended everything that we knew about science from that perspective many, many years ago. You know, it completely switched from the notion of everything was created to now you've got this big philosophy of everything evolved instead of being created by God in the past. So it affected the world in a way that's really difficult for us to comprehend. You can't imagine the effect that this book had on society. Not completely right away. It took a while, but right now what we're seeing is we're seeing this philosophy applied to many different things. But without diving too deep into that part of it, so Darwin believed, and many since that time, including today, believe that you can explain all species by means of natural selection. In other words, the origin of everything that we see today should be able to be explained by this process of natural selection. And I'm sure you've heard of natural selection and you've talked about it in your biology classes. So before we jump into exactly what it is, just a couple things to make sure that we keep straight here. So natural selection is oftentimes thought of as survival of the fittest, but it's not necessarily the survival of the fittest. Really what's surviving and what's being passed on every generation is whichever animal has the greatest reproductive advantage. So if you produce more offspring, but you're not quite as fit, then, you know, technically you are more fit because your genes were passed on to more people than the other animals. So it's not necessarily the biggest, the fastest, the strongest when we're talking about survival of the fittest here. The fittest basically just means you pass more of your genes onto more offspring. That's all that is. So I'm a big fan of dogs. I love dogs. That's my parents' dog, Kelly, from a couple of years ago. She has since passed away, but she was a fun little dog, and this is my son, John, back when he was about 1 year old. He was also a big fan of little Kelly. And so I'm going to use some dogs in an example here to show you exactly what natural selection is. So the two dogs I'm going to introduce you to are Bingo and Daisy. Now Daisy, yes, Daisy was raised in a wealthy suburban home. Bingo came from the wrong side of the tracks. But when these two met, they instantly fell in love, and they knew that they wanted to spend the rest of their lives together. And so it was only a matter of time before they decided they were going to have some puppies and start a family. It's a very important decision in the life of a dog. So, a little bit more about these two individuals. Bingo here has a gene, and remember, a gene is basically a collection of DNA letters that gives your body the information to make a certain physical characteristic. So this is a gene that codes for short hair in dogs. This is a gene that codes for long hair in dogs. They do not look like this if you actually zoom in on them, but you get the idea. Same thing for Daisy here. She has a gene for short hair and she has a gene for long hair. Now you all know and love your Punnett squares, right? Yes. So you know there are several different possibilities when they have little puppies. That puppy could get the short hair gene from dad and the short hair gene from mom and end up with very short hair. Or you could get the short hair gene from dad, long hair gene from mom, or the short hair gene from mom and the long hair gene from dad, and end up with medium length hair. We would say those genes would be codominant. Or you could hit the jackpot here. You could end up with the fuzzy gene from mom and the fuzzy gene from dad and end up with a super fuzzy puppy. And so those are the possible scenarios where you could end up with different puppies there. Now, this population of dogs decide they want to go off on their own, they want to leave home, they want to go from their warm place of residence in Atlanta, Georgia, and they go to the frozen tundra of Green Bay, Wisconsin. Now, a couple of things are going to happen when this occurs. So these are the four puppies here. Now, if you are a dog with very short hair and you try and exist during the winter months outside in Green Bay, it's not going to go well for you. Of course, we don't like to think about dogs dying, and I don't either. So let's just pretend they don't die in the snowy weather. Maybe they just move away, we'll say. So short hair dog is not going to do well in the frozen temperatures. Neither will the medium hair length dogs. But the fuzzy dog is going to be just fine. He's got all this insulation. Everything feels real good. He feels just at home in Green Bay. And it's only a matter of time before our fuzzy friend ends up meeting somebody else who shares his characteristics and is also very comfortable in Green Bay. And they decide to have their own little puppies. What kinds of puppies will these two dogs produce? Fluffy puppies, absolutely. So they only have the genes for long hair. So when they have puppies, all of their puppies will be very, very furry. And this is exactly why natural selection will never ever get you brand new animals over a long period of time. Before I get specific on this, anybody want to try and anticipate on what I'm going to say?
They're gonna have puppies.
Well, that's true, but like when we see this population of dogs changing from one generation to another. Why is it that these changes will never give you something other than a group of dogs?
Genetics.
Be more specific.
DNA.
Looking for something different. Good try though. So what's going on here is we start with a variety of genetic information in this original dog population. But through natural selection, the weather has selected out these dogs that aren't quite as fit for that environment, and you end up with dogs that are, and yes, that's change, but what we're doing is we are eliminating genetic information in order for that to occur. In order to get brand new animals over long periods of time through natural selection, you need brand new genetic information. Natural selection does not do that. It eliminates genetic information, or at best rearranges it. It's not a creative force. It's not something that can produce the new genetic information you need to get brand new animals with brand new features. So this is again, I feel like I'm repeating myself, just like with genetics and DNA, and we see our genetic code getting worse and worse and worse instead of better and better and better. This is the exact same story. Natural selection causes genetic information to reduce over time. It does not cause it to grow. So natural selection will never give you the brand new animals that the grand theory of evolution tries to explain. And there are lots and lots of different examples like the one I showed you. You probably have heard about Darwin's finches. So he examined that as food sources changed, the beaks on these finches also changed over time. So the scientific community likes to say, well, that's a change. And so if these species are changing over this short period of time, maybe if you give them millions and millions of years and have more and more changes, you'll go from a bird to a cow or something. They don't say that, but that's the idea. You go from one type of animal to another. But again, it's not whether or not things are changing. Nobody is arguing that these species change over time. But we have to ask ourselves, is this the type of change that is necessary for us to get brand new kinds of animals? And the answer to that question is always a resounding no. Another example that's popular is right here. These are peppered moths. And these peppered moths are sitting on trees here. And how many moths do you see in this picture? 3, very good. I wasn't sure if you'd be able to see the third one. You've got 1, 2, and 3. Obviously, one blends in better, so the other 2 are going to be more easily picked off by predators. And in this one, there are also 3, maybe 4. I can't tell. That might be one there too, but definitely 1, 2, 3. Obviously, these 2, maybe 3, would be much more easily picked off by predators again. So what's going to happen in that population is instead of having an even mix of dark and light peppered moths here, you're going to have lots of light ones because the predators can easily find and pick off those dark ones. So yes, that population is changing over time, but again, whether they're changing or not is not the real question here. The real question is whether or not those changes can give rise to brand new animals, and they can't, because you're losing genetic information. It's not just whether things are changing, it's whether you're getting the new information to provide the genetic codes for the brand new animals, and you're not. All right, finally something you can write down. Write this down. Everything was what?
Like cold. Like if they all the dogs moved to the cold spot,
Sure.
we just wouldn't have short-haired dogs.
Yeah, natural selection would
Like,
select
could it
against
go
them.
Back though?
No. If all you have are those long-haired dogs, and they're just mating with other long-haired dogs that have that dominant gene, you'd completely lose that genetic information, which is why natural selection is going the exact wrong way. You need an addition to information. So it's very important for us to be specific about our terminology here. Because oftentimes the scientific community likes to say, well, we see changes in this population of dogs, or we see changes in this population of birds, therefore they are evolving. But when you're talking about changes, if simply changing over time is the same thing as evolution, then I'm an evolutionist. Because things do change over time. Nobody can deny that. That's what we see happening on a regular basis in the real world. But we have to be very careful about what type of changes we're talking about here. So when we generally think of evolution, you have one animal branching off and eventually becoming another animal, branching off and becoming another animal, branching off and becoming another animal. And eventually you have this great big tree of life that Darwin envisioned of all these different animals in our world today. That's what we think of when we hear the term evolution. So that's how I'm defining that right here. And that goes along with big changes. You need to have brand new genetic information in order to get brand new animals, brand new different kinds of animals. This is also known as macroevolution, evolution on a big scale. And the things that you need for this to occur up top, this general theory of evolution, is completely different from the changes that you need for the special of theory evolution, which is something that we do see occurring oftentimes. So this is natural selection. This is what we just talked about with the dogs and the birds and the moths. These are small changes occurring in these creatures. Yeah, the creatures can change over time, but we don't see them changing into other kinds of creatures. And this is also known as microevolution. So when I talk about evolution in this section, I'm talking about it in this context, within the general theory of evolution. The big changes that you need to go from one big animal to another type of animal. And natural selection is the other thing. And these two are completely different processes. But the scientific community likes to connect them with the word change and pretend that they're the same thing when they're not. From this slide, write down the last 4 bullet points, please. So you're going 1, 2, 3, 4.
Just the bottom.
4, that's all. Don't even need the title. So what you're writing down now is just a play off of the previous slide. And it basically gives you the logic of Darwinian evolution. This is the same logic that you'll hear espoused in classes in the university setting and on in documentaries online or on the National Geographic Channel. So they like to pretend that the special theory of evolution, plus or times millions of years, will get you the general theory of evolution. In other words, small changes over millions of years will get you great big changes, or microevolution and millions of years will get you macroevolution. So again, kind of a summary of this is they're saying, we're seeing these small changes occur in this short period of time. If you extrapolate that over millions of years, you'd probably have brand new animals by then. And that's the logic that they're using. But of course, that logic does not work because they are two fundamentally different things. Natural selection, from the examples that we showed, natural selection most often reduces genetic information. At best, it rearranges it, but it does not give you brand new genetic information. And if you're going to go from one type of animal to a whole other type of animal, you need new genetic information for that to happen. You can't just say enough changes get you a brand new animal. Those changes have to come from somewhere. The brand new features and brand new characteristics of that animal have to arise. You can't get those just by eliminating genetic information. This theory can be called the general theory of evolution, and the evidence that supports it is not sufficiently strong to allow us to consider it as anything more than a working hypothesis. It is not clear whether the changes that bring about speciation, or natural selection, are of the same nature as those that brought about the development of new phyla, like big changes. The answer will be found in future experimental work and not by the dogmatic assertions that the general theory of evolution must be correct because there is nothing else that will satisfactorily take its place. So again, it's always nice when honest scientists, again, this is not a religious individual, this is a secular professor, when they admit that the evidence does not support the general theory of evolution. It supports natural selection, it supports the special theory of evolution, the small changes over time, but not the great big ones. From this slide, you're going to write the whole thing down. F 'em. Yes. Sure. Again, I can't stress this enough. We have to be very, very careful with how we define things. We have to be very specific with our terminology here, because in the scientific community, they're not careful with it. They like to pretend that all change is the same and that the change you see that gets you natural selection is the same change that can get you brand new animals, but it isn't. So when we're talking about the special theory of evolution, natural selection, microevolution, small changes, whatever you want to call it, this is the rearrangement of existing genetic information or accidental and almost always degenerative changes in that information. Natural selection, these small changes, otherwise known as speciation, that's compatible with the Bible and the scientific method. We see it happening on a regular basis. Nobody argues with that. But the general theory of evolution, that's the formation of new complex genes containing the instructions for making, for example, muscle cells, bone, nerves, feathers, etc., where none existed before. That's what we don't see happening in our world today. We do not see genetic information for muscle cells or bones or nerves or feathers ever creating those things where they weren't already there before. But that's exactly what needs to happen for the grand story of evolution to be true. And special theory of evolution over millions of years, it actually goes down, not up, because these changes are almost always degenerative. In the example that we used with the dogs, how could that be a degenerative change where you have those, just the furry dogs in the cold environment? Why might that not be a good thing over the long term for a population of dogs? Yeah, what happens in the summer? Or what happens when they move back to Georgia? Because now they don't have the genetic variability to produce short hair or medium hair length dogs. So it's degenerative, not just genetically for one population of dogs, but also for their descendants. These changes are going down, not up, just like in the previous section. The central question of the Chicago Conference was whether the mechanisms underlying microevolution, or natural selection, can be extrapolated to explain the phenomena of macroevolution, or, the great big story of evolution that we're used to hearing about. At the risk of doing violence to the positions of some of the people at the meeting, the answer can be given as a clear no. Bless you. Now, I get really, passionate about this stuff because having gone through the secular science system, both in high school and in college, this is the exact thing that I saw over and over and over again. And I saw many, many people lose their faith or at least feel challenged by it on account of what they heard in their science classes. This is the sort of thing you're going to hear in the science room when you guys leave these halls and go to different universities. The professor says, I see evolution happening in my lab. It's a fact, you stupid Bible-believing Christian. Might not say that, but that's what he's thinking. And so, because he sees this evolution happening in his lab, you automatically think, well, it's happening in the real world. Evolution is the whole story of how you get, brand new animals over these billions of years. But of course, in reality, what he's talking about when he's saying this is he's seeing these small changes that are occurring in maybe a population of butterflies, maybe a change in wing size or shape or pattern or something like that. And the changes that cause this are completely different and nothing like the changes that would cause this. And that's what you have to remember, if nothing else, from this section. Go ahead and write this down. See if you can get it down by the end of the hour. If not, we'll jump back in at this spot when we come back tomorrow.